Here we define the modulus of a complex number. So a complex number could be called z, and we would typically write it in rectangular form as a plus bi. But the modulus of a complex number is the distance that the complex number is from the origin in the complex plane. And so we often use the vertical bars for it to indicate distance. And so whether you know it or not, you might call these absolute value, but that's a very specific name for it. In general, the vertical bars mean distance, okay? And absolute value is a type of distance as well. So in this case, it's not called absolute value, all right? If you think of it that way, you could get confused. So make sure to understand vertical bars around a complex number mean modulus. Okay, so let's practice with this idea of what modulus is. For each of these complex numbers in these examples, I want to determine the modulus of z. Sometimes it's labeled as r. So I could say, instead of modulus of z, I could say modulus, or sorry, not modulus, but just, or I could just say r, determine r, okay? So here, in this first example, 3 minus 3i, if I want to know how far this point is from the origin, why don't we just draw a picture? So here's my complex plane, my real axis, my imaginary axis. I go to positive 3 on the real, negative 3 on the imaginary, and my point's right here. So if I look at this and I want to know this distance right here, my r value, or my modulus of z, that's the same thing, then I could easily set up a right triangle to figure it out. Because this is in rectangular form. I've got a horizontal distance and a vertical distance here, and I could easily figure out r using the Pythagorean theorem. So I know the r, or r squared, will be 3 squared plus 3 squared, which is 18. So r will be the square root of 18, which simplifies in lots of different ways. If you wanted to simplify it, you'd have 3 square roots of 2. I won't go into how to simplify it. Or you could get a decimal if it's so called, okay? So some kind of decimal answer. So the modulus of z, I like the square root of 18 for my answer, but 3 square roots of 2 is also good. Okay, let's do this one. I want to know the modulus of this complex number. I forgot to label it with a z, so let me type that in there. That's important because the directions say determine modulus of z. Let me go ahead and do that for these other two as well while I'm here. Okay, back to business. Z equals negative 7i. I need to plot it and then see how far it is from the origin. So my real component is 0. My imaginary component is negative 7. 1, 2, 3, 4, 5, 6, 7. So my point's down here. There is no triangle this time because my point is not within a quadrant. It's actually on an axis. So r, or the modulus of z, is actually just 7 because this point is 7 units from the origin. Okay? It's not negative 7. It's just 7. It's a distance. It's also not 7i. So not negative 7 or 7i. It's just the distance 7. Okay, 2 more examples to really get this down. This time my real component is negative 2 square roots of 3. So let's just say that's back here somewhere. So this distance is 2 square roots of 3. I could even label negative. And my vertical distance is 2, so I'm going to go up here to 2, let's say. So this is 2. Which means my point, my complex number, is over here. And I want to know r, which is this distance. So if I look at my right triangle, then my horizontal leg of my right triangle is 2 square roots of 3, and my vertical leg is 2. So r squared equals 2 squared plus 2 square roots of 3 squared. So r squared is 4 plus 12. So r squared is 16, which means the r, my modulus, is z. Of course, I could also be writing modulus of z equals 4, okay? So be comfortable with either of those. And lastly, we have negative 10, which goes to negative 10 on the real axis. So I go back 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My point's right there. My imaginary is 0, so I don't move up or down. And so r, or the modulus of z, is 10. Again, no triangle to calculate that. No Pythagorean theorem. And that's all there is to the modulus of a complex number.